Thank you, Yang, and thanks for having me here. I should first apologize by saying this is a different paper than was included in the background materials, so sorry about that. This is related, but that was the one that had a draft ready to show you, and this is the one that I'm more excited about because it's newer, I guess, as we often are. It's joint work with Vernon Henderson, who's recently moved to LSE, and Uwe Dijkman from the World Bank. And so what we're interested in sort of, to put this in context of sort of the urban literature, urbanization literature a little bit, there's this claim in the literature in some sense that urbanization in Africa is different than elsewhere in the world that's been made from a few different directions. So one, broadly speaking, the idea is perhaps, whereas we see people pulled into cities by economic growth in many regions, it may be the case that it's more common in Sub-Saharan Africa that bad things in rural areas are pushing people into cities, out of rural areas and into cities. Be that climate change, or be that climate like I'll talk about, or civil wars, or other things. So just this general idea that the pattern, that the difference between that urbanization and growth relationship is different was put forth by Faye and Opal. In other work, the paper that was posted, Vernon and I and Mark Roberts found that we see that there are some things that essentially there's some things that where urbanization looks quite similar to the rest of the world in a lot of ways, but in the sense that as underlying drivers of growth, like human capital growth, increase, that we see more urbanization. At the same time, there's a difference related to trade shocks to agriculture. There's a set of papers that look more specifically at climate change. So in particular, Barrios et al. See a more pronounced effect of climate change in terms of, and they see more of a response of urbanization to climate change in Sub-Saharan Africa than in the rest of the world, using exclusively cross-country evidence. So in some sense, what we're doing is looking within country. We're sort of redoing their work, looking within countries to compare across regions. There's been also some work within Sub-Saharan Africa, specifically on using migration data, particularly in Burkina Faso, that suggests that we see some climate impacts on people moving into urban areas, but actually an potentially even bigger effect of people moving between rural areas. And unfortunately, we're not really going to have the data to look at that as well. So the question, the way we're going to think about the question really is to ask whether declining wetness, and I'll explain what I mean by wetness more precisely soon. This is part of, I think, what Saul was talking about, the proliferation of various different kinds of measures one uses to look at climate. So sorry for that. We want to look at whether that has been sort of, in some sense, driving people out of rural areas and into cities in Sub-Saharan Africa. So in some sense, the motivation on the climate side is this sort of tangled spaghetti so what I'm showing here is normalized to being, I'm looking at trends across across 15 or 20 countries over the past 60 years in climate as compared to their initial average. And we see this general downward trend, especially in the first half of the period, but also continuing somewhat after that, right? So this is this measure that I've been talking about as wetness, right? And basically the idea here is that in terms of, since ultimately the channel is about how precipitation affects agricultural livelihoods, right, in rural areas, we want to sort of take precipitation data, but then control for the fact that essentially water evaporates more quickly when it's hotter, right? So it's often called an aridity index that essentially divides precipitation by a nonlinear transformation of temperature known as potential evapotranspiration, right? That's sometimes called an aridity index. The confusing thing about that language is that the higher the number, the wetter you are. which is an odd property of an aridity index, right? So we reterm it. It doesn't sound great, but for now we're just going to call that wetness. Right. Sure. Yeah.
Why is this decline trend happening? Is it because of deforestation or some man-made processes that this is happening?
I mean, I don't think on a continental scale, I don't think we expect that things like deforestation could be driving something like this. I mean, I think that this is the kind of, we've seen warming over this period globally, I think. I mean, this trend has been stronger in Sub-Saharan Africa than the rest of the world, and indeed that was the point of the Barra, Spitnelli, and Strobel paper, but I don't have a great answer for this. I don't think you could say that it's local human generated in some sense, right? I mean, to the extent, I haven't seen good arguments that it's about local deforestation per se. We're going to be, we have our own, I mean, as all of us in different ways here, we have our own sample selection problems. And here, what we're going to be doing is be looking at as many countries in Sub-Saharan Africa as we can find, for which we can find at least 2 censuses that we think are somewhat reliable, that have certain properties within the past 50 years. So we need information at the subnational level on population by urban and rural, split between urban and rural, right? We actually collected a bunch of migration data as well, but it turns out to be extremely inconsistent across countries and over time. Now, there's been some talk today about changing definitions of what is urban, and I think that the key to note here is that since we'll be comparing countries over time, the important thing is not to have definitions that are changing dramatically within countries. So we completely acknowledge that what is urban will be different across countries, but as long as Ethiopia is defining urban in a somewhat consistent way between the censuses we look at, that shouldn't be, then we should still be capturing urbanization in some important sense. Unfortunately, we have to exclude the 2 biggest. So we generally look for the largest countries with, and we also tried to oversample in some sense the Sahel, where we expect the biggest effects. And we were limited, of course, by what we could find in the libraries we had access to. So we had to include South Africa because they had a lot of changes in boundaries in ways that we couldn't really account for, and we're concerned that they were driving many things. And Nigeria, just because of a history of censuses, highly politicized censuses that we weren't really sure how to interpret. So ultimately, what we're left with is 17 countries with about 200 districts overall, on average about 3 censuses per country. And I mentioned the changing definition. So in only one case where we really knew that there's a changing definition, namely Kenya, we actually, in some sense, econometrically treated it as 2 countries, 3 censuses during an older urban definition and 2 with a more redefined set of urban areas. Okay, so these are the countries we're going to be looking at, colored here by the number of censuses we have for them. So as I mentioned, we do, in part by design, we have more in places that we think are going to be especially susceptible to, sort of having large areas that are on the edge of being able to have rain-fed cultivation. And we're, as you'll see, we're going to attempt to split our sample to look at places that we think are going to be especially affected. Here we're looking at just in the first 20 years of our period, sort of what sort of initial conditions were like in some sense. So this is how I mentioned these are the sort of drier areas up north and to some extent in the south and east as well that we're going to be capturing. And then in terms of change over time, we see in general almost everywhere getting on average drier. So we're averaging over this 20-year period at the beginning of our sample and then this 20-year period at the end of our sample and looking at the difference between the 2 periods. The areas in yellow are about the same. The areas in orange have gotten drier. And so essentially almost nowhere we've looked at have gotten wetter. I mean, there's extremely few people here to have been, and wetter means from extremely dry to, I guess, barely, slightly, extremely less extremely dry. So that's sort of the variation we see in terms of what changes have been going on. Now, just to put it in context, so we have a. I'm not going to go through our explicit model, but it's a fairly standard model of where the idea is just that people are going to move between urban and rural areas in order to, if they can improve their real incomes. And so the idea is that if increased aridity essentially makes agricultural livelihoods more difficult, then that's going to induce some people to move into the cities. Now there's other possibilities that we're going to look at a little bit as well, besides just urban and just moving from a rural to an urban area. So one is the idea that potentially, to be clear too, we're also looking at this happening essentially within districts, right? So moving from a rural area of a district or province into an urban area of the same district or province. Another possibility is, of course, to move across districts, and particularly one might be interested in looking at moves to a so-called primate city, which, a city where, as it was mentioned in the morning, where you might have a large fraction of the economic activity in a country. We can say we're going to try to do something with that, but it's sort of harder to do statistically, and you'll see why. There's also the possibility, of course, moving in a sectoral sense, right? So moving from on-farm to off-farm livelihoods that are potentially less directly affected by climate conditions, right? And we'll be able to look at that. And finally, we'll look at a sort of something potentially working in the opposite direction, namely that there are, these cities may not be filled with people whose livelihood is directly affected by farming, right? By climate through farming. At the same time, if all the farmers around your city are finding it harder to make a living as farmers, that may affect their ability to buy things from you in the city, and overall just sort of hurt the prospects of a city that is essentially a consumer city for agricultural areas, right? And so that could sort of be, we think that might be especially important in places where the town is more likely to be linked to agriculture than, say, if it's like a mining town or a town with manufacturing. We're also going to do look a little bit more tentatively at just sort of how this effect might differ in other dimensions. As you're going to see, it's going to be hard to get a real consistent story of this, but this is just to say we tried. So we will look a little bit based on whether things vary based on the initial urbanization level of the district. There are some econometric problems with doing that. We'll look a little bit sort of spillovers in terms of how these processes are spatially linked across neighboring districts, and then some differences between how sensitive agricultural conditions may be to today's climate, based on whether they have irrigation, whether their soils are able to retain water from one day or a month to the next. And then also a little bit more about sort of, instead of just annual averages and multi-annual averages of rainfall, what's going on within years, right? So you might be worried about, if all the rainfall is concentrated in 1 month. So we essentially construct a Gini of rainfall within a year. Also something about, because we're essentially looking across intercensal periods, which in this context are sometimes closer to 20 years than 10, but always at least 10 years. We can look a little bit about changes in volatility during that intercensal period, but that's also going to be a challenge. Getting that sort of second moment out of the data is going to be challenging. We also look at, briefly, at sort of, you'll see ethno-linguistic fractionalization. If a city, potentially, if the city you would move to is occupied by a different ethnic group, it may make moving to that city more less of a good idea for you. So the way we're going to do this econometrically is we're going to be predicting the share urban, so the fraction of the population in the district that is living in urban areas for this highly unbalanced panel in the sense that every country has different census years, right? And so they have these very irregular census periods. And we're going to essentially be differencing between consecutive censuses within each country. Okay. So over these, so if you think about, when I say highly unbalanced, I mean in the sense that the 16 countries had censuses in 33 different years, right? Which means a fully balanced panel would be sort of I guess 500 country years, and we have data because that's when the censuses were taken in this period from 53 of those, right? So we're going to deal with this by taking, like I said, these first differences across censuses essentially, and then creating an annualized growth rate in both population and in our wetness measure. And so that's going to be equivalent to controlling for district fixed effects for anything that is constant across time for each given district. And we're also going to control for country by year fixed effects so that any way that a whole country's condition changes across censuses will be accounted for. So anything we're leaving out has to be something that varies across districts and over time. And so that in terms of what that country year fixed effect is including, it is capturing whether overall the country is urbanizing, so that we're looking at really what's happening across districts in the urbanization. It's controlling for changes in the definition of what's urban, and so it is really just these within country differences. So in Greek, or I guess mostly English, but a bit of Greek. What that means is that we're looking at this annualized growth rate as a function of the country year fixed effect here, that country by year fixed effect. And then we're going to look at this wetness W for district I in country J in year T minus some lag, right? And so because climate conditions, you might not expect this to have an effect in the immediate year of a decrease in rainfall, but rather that these things get spread out over time. We're going to both smooth across years and then also look at effects lagged by about 5 years. So in practice, we're looking at the smooth effect from 4 years prior to from 6 years prior up until 4 years prior to the census.
So just to understand,
Yeah, sure.
sorry, Adam. So that's urbanization at the district level.
Yeah. So the fraction of the district, an annualized change in the fraction of the districts.
People are moving across districts in order to urbanize. You're going to.
No, so sorry, we're not going. Yeah, no, we're not going to be able to deal with that because the migration data are not. So that will. I mean, in some sense, it's operating in the same. I mean, if people are moving out of your rural area into someone else's urban area, it's going to work in the same direction, but in a less clean way in some sense, right? Yeah. And I should also say, I mean, district or as you might have noticed. So I'm talking about. I said it ends up being 10 or 12 districts per country, right? So I mean, in some contexts, you'd think of these more as provinces, right? So these are more often sort of first level administrative units. Right? So we're going to do this in a few different ways. So first we're going to do this for the full panel of about 500 intercensal periods, district intercensal periods, with these country year fixed effects I mentioned, and then lagging the climate conditions by 4 years and smoothing over a 3-year period. We're also going to just look at long differences in the sense of the first census in a country versus the last census in a country. And the idea there is it's sort of essentially almost generational change. So we're limiting to censuses that are I think at least 17 or 18 years apart. So it's sort of like I'm making a choice that might be different from my parents' choice, based on what has changed over across generations, right? And we're also going to do this both for all countries in our sample, and then restricting to countries below a cutoff level of wetness. So this is just for I guess full disclosure here. This is the panel for all countries, right? we see this effect in the expected direction, but quite noisy. So this is the expected direction because we essentially, if a country grows, so a negative growth in wetness, so getting drier, increases the urban fraction, right? So on this sample, we see really just a noisy effect. If we then split, so this is somewhat problematic, but I think useful to look at heterogeneity. That if we interact this result with the base share urban, so in the initial year, what fraction of your how urbanized was your district, we see that this essentially has less of an effect. It moves in the opposite direction, right? So it has less of an effect in the more urbanized districts. So that, in some sense, if you're fully urbanized, this is not going to have a big impact. Right? Things start to look more interesting in the other samples. So first of all, if we limit ourselves to arid countries, right, then we get this coefficient of about -0.5. And so to give you a sense of the magnitudes there, oh, sorry, now I lost the magnitude. So, so the base share urban is about the mean. Oh, sorry, and I mentioned that with this heterogeneity here. So again, it's more of an effect in the places that are the least urbanized already. Okay? And so this, in terms of the magnitudes of this, essentially is that if you this appears to, if you move one standard deviation up in aridity, this sort of knocks off about one standard deviation down in aridity. This knocks off about 30% of the urbanization that we expected we would expect to see for the mean aridity.
Quick question about the fixed effects.
Sure.
When you say country year, because you have this call provinces,
Sure.
you don't just have, like, as is often the case, a set of country effects and then a separate set of year effects, but you have a separate dummy for each country year combination?
Exactly.
Okay.
Yep. Yeah. Exactly. Because we have the multiple districts per country and multiple countries per year, we're able to add those in. Yes. Exactly. The results are a little bit more stable for if we just look at these longer differences, right? These sort of generation scale differences, right? So this is for all countries again, right? And it's again around this 0.5, and again decreasing with higher urbanization, and that if we now just do the long difference, this generational difference for the arid countries. It's again about 0.5, although a little bit noisier. The sample has, of course, gone down by this point, and when we adjust arid countries, we have 94 districts, and of course, just two years per country because it's the long difference. Great. So, all right. So I do have the quantitative interpretation here. Great. So, so the idea here essentially is that we see this elasticity of about -0.5 in the arid countries, as well as for the long difference for all countries overall. And a one standard deviation increase in wetness, which I know is a slightly odd variable here, is about 0.015. And this implies that's going to be a less than 1% change in urban share growth as a fraction of the initial urban share, right? So that since that, our mean for that urban share growth is about 2%, again, of the initial urban share, right? So not 2% of the population, but 2% of the initial urban share. So this is what gives us about a 30% reduction in moving in getting one standard deviation wetter. Now, so I mentioned we tried to look at heterogeneity a little bit. Would it help at all if I turn this slightly this way? Can people see with the it will do the same thing. Okay. Yeah. Sure. So I mentioned, the one thing we really see somewhat consistently is this idea that with the higher initial urbanization level, we see less of an effect of change in climate, right? For all of the other things we looked at, we don't see much. And these are essentially interactions between, in most cases, these are interactions between some fixed geographic thing like soil conditions, right? Or potential for irrigation, or in some sense, an old irrigation data set. And so we don't, there's some so it's fairly noisy evidence about each of these, really. So I won't go into detail about any of this. Okay, so I mentioned that there's a few different ways we want to extend this. And so one is like I mentioned, movement out of districts into the primate city of the same country. And then the sectoral movements, and finally these urban-rural linkages. So the problem with looking at movement into primate cities is that essentially our unit of analysis becomes the country by year, right? So we're down to essentially a sample of 35 country years, right? So this is, I'm sorry, the largest city in the country. Yeah, in the country. Yeah, sorry. Yeah. Would it help if I wave in front of, if you know which one it is?
A lot of it's coming from the window out.
Right. Yeah. No, I thought. Yeah. So let me see. Yeah, we think it's the big one up here. Hey, thank you. I thought that might do it. Thank you. So here, I mean, we see something that looks broadly similar in the sense that you have higher in this first column here. If you have higher, if you have more wetness, that seems to decrease the fraction of the growth rate of the primate city population. But it's pretty weak in general. And then if we control for the annualized growth in the national population, it becomes even weaker. So there's not much to, I mean, I think that this is, if there were a better way of looking at this, I would be very interested to see how this changes primacy, the fraction of the population in the largest of the urban population in the largest city. But it just sort of, I think, econometrically somewhat more challenging to look at.
Adam, just a clarification
Sure.
question. So we did average growth in wetness. So that's district or province level growth in wetness.
Yes.
Averaged by
Across all.
what are the weights? Population or land share based?
I'm sorry, now you've got me. Yeah, I can't remember what we weighted with. I think we tried it a couple different ways. I think we did. Yeah, I think we tried it with land and population, but I don't remember which one this one is. I don't think it changed dramatically. Yeah, so. Okay. So we want to look at. I mentioned this issue of changing, of employment is a different margin of response, right? And in part because we do see these over time a substantial increase in the non-farm sector in the non-farm rural sector in several countries in Sub-Saharan Africa, right? So these are data from primarily demographic and health surveys and a couple of censuses from IPUMs, suggesting that the share of agriculture in a survey from the 80s or 90s. The share of agricultural employment in overall rural employment went down quite substantially in later surveys in the past decade, right? Much less so, I mean, much more so in some countries like Malawi, Niger, Benin, Senegal, than say in Chad or Burkina Faso, right? And so we want to see if there's any, if this is a margin that where climate played a role. And so we're going to do this using demographic and health surveys for 18 countries and 43 surveys. Again, this sort of very much unbalanced panel. And we have them over this about 15-year period from the mid-90s to 2011. We restrict the sample to rural residents. And part of the reason we don't start till 96 is that we want to make sure to have that after that, it's much more consistent that DHS asks questions about what you've been doing over the past 12 months, right? So the concern, of course, is that if your country's survey, or even just your household, was surveyed at harvest time versus in the hungry season, like you could have a different answer about what you currently do, right? So at least people are asked to say sort of what their general, employment is over what their main form of employment is over the past 12 months. Okay? And we also need surveys that have GPS data so that we can link them to the weather data. And in practice, these are not, of course, panel surveys, but we make them sort of pseudo panels in comparing broad locations over time by comparing. So every new survey, different clusters are sampled, but so we sort of compare surveys from the initial clusters from the initial survey to a set of nearby clusters in a later survey, essentially. And so here we're going to be looking at sorry, this should be updated. This is actually a sort of trinary outcome, essentially. But we're looking at an employment outcome for individual I in supercluster C, in country J in year T. Far too many subscripts here. And we're going to be controlling again for the country and year of, and then and at various times either a fixed effect at the supercluster level or at something like a province level, which is done slightly differently than we do it in the other data. And then we're going to control for the things that we have in a DHS, so age, the sort of typical things in an employment regression that are available, so age squared for employment, and for education dummies. I think, and then again using wetness as the main variable of interest. And so we'll do it now again we'll be looking at sort of panel and long difference, but now instead of looking at sort of drier and less dry countries, we're going to look separately at men versus women who are surveyed separately in the DHS. Men are surveyed much less regularly and with smaller samples generally. So this is the results for the panel, right? So in this, we see, and then the other thing I didn't mention with this, of course, so these are, so we essentially have three outcomes, right? So we're dividing people into whether you work in agriculture, whether you say you work in some other, in some other industry, or whether you say you do not work. Now I understand that these are, these are questions that one can interpret in many different ways, right? In the context of rural Africa, what I think when we're looking for an effect, we were thinking that the idea is that somehow if people are changing their answers in the way that in the direction that we are thinking about, then we think that something must be going on. We know that people may mean different things by saying that their main form of employment is in agriculture, right? But to the extent that we see a change, we think that something's going on. I thought I saw a hand over here.
I was going to ask, is employment like wage employment only, or does subsistence farming go into working in agriculture?
So unfortunately, so a subset of the surveys do ask about wage employment, and we have not limited to wage employment yet. But this is the expectation here is that this is not exclusively wage employment. That this is work in general, right? So there's definitely an issue of sort of what exactly is meant by work. But to the extent that someone says that they primarily work in agriculture, or they say that they primarily do not, we think that something interesting is going on here. So the three columns, the first three columns are women, the second three are men, and then we have these three outcomes from linear probability models, OLS, and we see that with higher wetness, fewer women say that they're not working, and more women say that they're in agriculture, and we see that with men, the male results across specifications tend to be much more noisy, but here at least it seems like the changing margin is sort of between people saying they work in agriculture versus saying they work in other sectors. Yeah, Lakshmi?
So do the DHS ask about any migrant members of
So the data on that I think are spottier as well. I mean, to the extent that people are leaving these rural households, that would work. That's potentially part of the. Essentially, who you have sampled is who is left over in the household. So I think.
Right, but I think with asking at the household level, things like, do you have a member working in a different place?
I think much more spottily. I mean, I think that would be a good area to.
Many of the SMS surveys ask these questions.
Yeah, no, that's true. So I think, working with DHS has this benefit of working across several countries, but you get into some questions like this where I think the employment questions are better standardized. I think we should look more into those, but
You can document the migration looking more, right? Now we're
Sure.
assuming that this acting through migration, that they
Oh no, I'm not assuming that it's acting through migration. I mean, it could be. We're talking more about.
But this one, not
Yeah.
something that initial urbanization is
Oh, the initial urbanization. Sure.
moving, therefore it's happening.
Right.
You can show it directly, that would be very nice.
Yeah, no, that's absolutely true, right? Yeah, so of course, implicitly in the other stuff, like I said, that the census migration data is very unstandardized, and so we're of course conflating migration with mortality and fertility responses, certainly in the previous stuff. Were there other questions I was missing? Okay. And these all have these what I called supercluster fixed effects. So that's 4,000 spatial fixed effects across the 17 or 18 countries, depending on whether I'm looking at men or women. If we instead use a multinomial probit, we get broadly similar results for the women. Again, it's mostly off of agriculture versus not working, but you also see some impact on saying you work in another field other than agriculture. Yeah?
Sorry, could you just clarify again how exactly you're interpreting the findings?
Sure. Sorry. So essentially, what we're saying is that as wetness goes up, so farming conditions become more favorable. The people sampled in these rural areas are more likely to say that they're working in agriculture, and less likely to say that they're not working, or as their primary activity over the past, or working outside of the house, essentially, over the past 12 months. That's the idea. And so, and for men, they're more likely to say that they're working in agriculture, and less likely to say that they're working in some other sector, in retail sales or in something else. Let me see. So I said broadly similar results for women in using a different specification, looking at a multinomial probit, so explicitly controlling looking at all three choices at the same time. Whereas the results for the men become much smaller, essentially all go to zero. So we think, and in general, that's the case that as we look across. I mentioned that we also tried this with long differences. The women's results, I guess I don't have tables for that. I didn't want to show too many tables, but the women's results sort of go through. The men's results are, again, they're sort of, they tend to be more just noisy zeros in most specifications. So the last margin we're going to look at is at this idea of that you might have an impact on local city growth, right? So that there could be that if agricultural conditions get worse in a rural area, the nearby cities could be much worse off. And the way we're going to say that these cities might be much worse off, in the absence of any better measure of overall economic activity in a city, we're going to use satellite data on lights at night, which is certainly an untraditional measure of such things. But it's something that in previous work we've shown is highly correlated. So growth in lights at the national level is highly correlated with growth in GDP at the national level. In other work I've shown, I've used this as a measure of city economic activity in looking at transport in Sub-Saharan Africa. So we're essentially taking these we have these 1 kilometer pixels. Information aggregated across sort of a broad measure of how much light is emitted into space, average over all the nights that the satellite's capturing a given 1 square kilometer pixel. We aggregate that up to sort of contiguously lit areas that we call cities, which I'll show you more on that soon. And then we essentially have a city level panel between 1992 and 2008. Actually, as of, I think, yesterday, I know it's now through 2012 available. And then we're going to record rainfall within a 30-kilometer radius of the city, outside of the lit area. But so what we're thinking of is essentially nearby rural areas from a rainfall data source that combines information from weather stations, which are fairly sparse in this region, as well as satellites, a different satellite. And then because these are essentially all satellite-based information, we can look at essentially almost all countries in Sub-Saharan Africa, right? We do some other sort of technical things in terms of removing places where the light is coming from just flaring oil wells. And we also excludes places like sort of Kinshasa and Brazzaville, where it's two cities on the border, and we don't really know whether the light, there could be some spillover, and we don't really know which light, whether light's coming from one city or the other. So we exclude cities like that, on a border like that. So just to give you some idea of how we're doing this in terms of what cities look like. So these are the outline of the lit area for an anonymous city. Each of these is a 1 kilometer pixel, and over time in the city, going from the gray to the yellow to the blue to the pink to the black, the city light is expanding. This is just sort of areas that are lit or not. Of course, for each pixel, we actually have a number between 0 and 63 of how much light is coming out as well. But this is just to show you that we see the city is expanding, and then an area a contiguously lit area we then call, and where we have some information from a gazetteer, from a census, saying that there is actually population there, we call a city, right? As opposed to just a piece of noise from the satellite data. And then we calculate the rainfall in a 30-kilometer radius around each of them. So here, the specification, we're going to be looking at the log of lights plus a constant as a function of rainfall in the contemporaneous year, as well as in the previous couple of years, to see whether this has an effect over year, a changing effect over time. And again, because we have all this variation within country as well as over time, we can control for city fixed effects. We can control for year fixed effects, as well as country-specific linear time trends. Now, and one last thing I should say before I show the results is that we're going to split our sample into the countries where we think, and this is still a bit of a puzzle, and I'm interested for everyone's feedback on this. We're going to split into countries where we think that agriculture is especially likely to be affecting what's going on in cities, namely countries that have a large share of agriculture in GDP versus countries that have a relatively low share of agriculture in GDP. So the first, I'll show you the results where the share of agriculture in GDP is relatively high. And here we see this, in the first column, this is a positive coefficient, meaning that an increase in rain increases, increases lights in the city. We see some evidence that effect persists into the next year, some weak evidence that might persist into the next year, but by the time we add in a third year, that sort of washes out. So it appears to be mostly a contemporaneous effect. This is a lag of 1, this is a lag of 2. We can do some control. So there's many reasons why you might, there are many reasons why you might worry about light as a measure of economic activity. A couple, and I'm happy to talk about some of those in questions. A couple you might be particularly worried about in this context is the fact that places, especially in this region, get their electricity from hydroelectric dams, right? So that it becomes easier to produce electricity and therefore light in years with a lot of rainfall. If we control for the fraction for a binary indicator of how much of a country's electricity comes from hydropower, that doesn't seem to I mean, the point estimate stays quite similar, but things get somewhat noisier.
It's almost double.
It's actually, yeah, it's right. It actually goes up. Right, compared to this one, it goes up substantially. So that.
Added error too.
Yeah, exactly. Now, if the things also get a little bit noisier if we control for the fact that whether your nearest power plant to your city is a hydropower plant for a subset of countries where we have that kind of information. So again, things get a little bit noisier, but it seems to be that I mean is a somewhat stranger. Given that you have national power grids, that becomes a somewhat stranger control, right? Because you don't necessarily think that it's the nearest power plant that's giving you your electricity completely. And then finally, it seems like this effect is a little bit smaller in places in larger cities, right? Which sort of makes sense in the sense that larger cities may be more diversified, less tied to local agriculture in the area around them, right? So being a city, so this essentially means that the effect goes away for cities over 50,000 people. So this is about sort of small agricultural trading posts, right? Now the results we're having more trouble explaining, I guess, and I leave this in the spirit of presenting work in progress, I'm interested to see what people think. We actually find negative and significant effects for places with a small share of GDP in agriculture, right? So for initially this, by pure coincidence, the first time I did this stuff, I did my sampling on, I was able to sample countries that were predominantly like this. Not because I was trying to just get countries like this, but that was just sort of where I had data for various reasons. It turns out in the countries where agriculture is less important, not only does the effect go away, but it becomes significant in the opposite direction. And so this is something we're still sort of puzzling over and trying to figure out why it might be the case that with more rainfall, economic activity or lights would actually go down in nearby cities compared to places where rainfall was lower within that country.
This may sound stupid because I know nothing about how this data is collected, but does cloud cover affect the measure of light?
So it could make it noisier, right? So I mean, in the sense that so they can
So
only
you
get
a lot of rain, like there's light.
right.
You're not seeing
Yeah,
it.
no, that's true. And actually, that's something we've thought about less in this context than we had in previous papers, and we need to be thinking about more. But so that could make things noisier. You could get some attenuation there, but it seems less plausible that it would turn in the opposite direction. But no, I think we need to think about some of that a little bit more. And I guess that's pretty much what I have for now. I'll be interested to hear your comments and questions. So I mean, just to summarize, we see this effect. We think that lower wetness, more dryness, essentially we see some evidence that that's pushing people to, or increasing urbanization in some districts, which we see as evidence of essentially pushing people out of rural areas. It seems as it also may be playing a role in pushing people out of the agricultural workforce. And it also, in primarily agricultural countries, it also may be reducing economic activity in small cities where local agriculture is sort of an important economic driver.
Okay, open up to questions.
So there's a lot here. I think most of my comments are connected to the first part of your talk with the country level and province level, though some might spill over. And just a couple of brief thoughts we could talk about later. One, I was thinking about, you're talking about what's going on in the countryside or in the agricultural area, and not so much about what's going on at the same time in the city. Now you have time and fixed effects and country fixed effects, but so for example, some of these things might be highly correlated with wetness. I'm not saying causally, but for example, marketing boards. They tended to be, to my knowledge in Africa, more prevalent and more mispriced at the time when things were wet. And how does that affect your estimates if it does at all? And just in general, I think I like the idea of that framework. There are a whole lot of policy questions in addition to climate questions that you could conceivably address, the so-called urban bias literature and so on. And let me not say more because time is short, but we can fill in later.
Sure. I mean, I guess at this point I'd just say thanks. I don't know. Yeah, I'd have to think about. So marketing boards would essentially be dampening an effect in some sense, right? If it means that people,
I'm not saying
yeah,
they tended to be early when it was wetter.
right,
There were, to my knowledge, more marketing boards, and there was a bigger gap between the price they offered farmers and the price and world price.
yeah. So I guess the key then would be how that worked within country. I mean, I think the key would be to think about how that worked
Yes,
within
exactly.
country, right?
So that would probably have that would be a bigger issue perhaps with your primacy measures where you don't have the ability to use
Right.
all the country time fixed
Yep.
events that would pick that up.
Yeah,
But
yeah.
it's also interesting on its own account.
Sure. Yeah, no, absolutely. Thank you.
Okay, I'll go over Stephen first.
My question is the research was on countries in Sub-Saharan Africa where more than 50% of labor force is in agriculture. It's like from 50 to sometime 90%. And that is the impact of climate change should be higher in those countries. But if we, in terms of urbanization, of course, but if you take a country like US, where the share of labor force in agriculture is like 15, only two. Labor force in, only two, so, but have something like 15, thank God, and we should expect less urbanization in US. So what if we took US like control group and African country like experiment group, a treatment group, and to look at the difference to see what exactly can be explained by the climate change. Or what if we take a country like Saudi Arabia, where people are not involved in agriculture, but where exactly urbanization is still growing. So I think, did you think about that to see what exactly is explained by climate change in urbanization in Africa?
So maybe I can answer that in the context of sort of where this study came from. Was that this Barrios, Bertinelli, and Strobel paper I mentioned that was cross-country was sort of comparing Africa and the rest of the developing world, and arguing that part of that essentially Africa had worse climate trend, had climate trends that were worse for agriculture over the past half century or so, right? So in that sense, some work has been done to do those kinds of comparisons. I mean, I think that the advantage, of our study is because we're looking across places within countries, so that each country is its own control in some sense, right? So I'm not sure that it would help much to use the US as a control because, I mean, there's so many other things going on here that even the climate trends have been different. So I wouldn't expect, I think you were saying initially, something about expecting an opposite direction effect in the US. And I think in the US it would have a lot more to do with sort of the capital intensity of farming and things, sort of different margins. So I would be hesitant to make too many comparisons in that direction. Right. So no. So that would be yes. Looking at the historical U.S. could be very interesting. Yeah. No, that's a good point. Yeah.
Okay. Question?
Adam, so if I understand, so why is the interpretation not pretty straightforward in terms of agricultural land values? In modeling that I did with our global urban land use data and several other studies show that the value of agricultural land is an important determinant of the extent of urban land use. And increases in agricultural land values will restrict the supply of land to urban areas, making cities more compact, making housing more expensive, presumably. And so isn't that just a straightforward interpretation of the channel through which your first result, not the light result, is working? If you have an increase in wetness, it increases the value of land being used in agriculture, and restricts the amount available for urban use, and so fewer people flow into urban areas. And it could also increase, I mean, it's a little less clear what the effect's going to be on the agricultural wage rate, but it's not implausible that the value of labor in agriculture could also rise, and that further reduces the incentive to migrate to cities. So that seems one possible pathway for explaining it. Sure. And in terms of the light data, there it's a little, I mean, I think a similar pathway works. The problem is you have these two different results, and I think reconciling those is possible by realizing light is a proxy for overall GDP. And so what you have to think about is how is this increase in wetness, which is going to add to agricultural land productivity, how is that going to affect aggregate GDP? So if it increases, I mean, in places where agriculture is a very large component of the economy, that increases GDP, and that's giving you more light, and that's what you find. And where it's a low amount, there it's a little more tenuous to make the argument, but I think we could probably write down a model that would give you that.
I guess I'm not, they would give you the opposite effect because agriculture is a low fraction of GDP already.
Right. So, but in the first part, it seems straightforward, does it?
Oh yeah, so in that sense, I'm not sure. I don't think I disagree with you at all. I mean, I probably didn't articulate it well, but I mean, I think we have a wage channel in our model. I don't think the idea that when agricultural conditions get worse, people move into cities, that's, I think, fairly straightforward, and that's what we're showing, essentially, right? No, I don't think that's a big puzzle. I probably didn't say this clearly. Among other things, I probably didn't say that very clearly, that I think that this very, very last slide before the conclusion is a puzzle. The other stuff I don't think is at all. I think it's quite consistent with what we expected in some sense. I mean, there's you know, knowing what the channels are is challenging, and that, you know, I think in that sense, I think this is really a first pass at all of this stuff, right? But no, it's absolutely consistent. I mean, yeah, we focus on wages. There could also be a land price channel, but yeah, no, I don't think that it's a shocking result in any sense. Yeah.
More questions?
I think this is similar to Stephen's points, or maybe just another way of saying it, that you yourself said at the beginning of the presentation, you're expecting both an income and, in a sense, a substitution effect, right? Substitution between agricultural and city, or, you know, non-agricultural urban employment, and overall income. And that should be what explains, right, the difference between your results between very agricultural countries and not so agricultural countries, right? That doesn't that,
a substitution effect?
with that in countries where a much higher share of income comes from agriculture, this overall income effect of the country as a whole becomes poorer, and therefore there's also less economic activity even in rural centers, would be larger than the substitution effect. I think that's in some sense what Stephen was also suggesting.
I see.
So this might explain then this difference between the less than, was it 20% and more than 40% agricultural.
Okay, I'll have to think about that more. But it seems a little weird that could flip every. I mean, I see it. I mean, it's a good point. It seems a little weird to me that could. It's surprising that would flip everything completely in the other direction. You know?
Well, these are sort of stark cutoff points that you're using there, right? That might be enough for that.
That's true, and I should add, if we change to 15, 25, whatever, we can. It looks pretty similar if we use different cutoffs, as long as we keep some sample in both categories. But we'll have to think about that one.
Okay, unfortunately our time is up. So for